Okay guys, we are continuing on with our chapter on factoring, and today we're going to factor trinomials. So what you need to remember, what's factoring and what are trinomials. Factoring is the reverse of multiplying or simplifying. So, let me get my stuff to work here. There we go. So previously we have had problems where we were told to simplify, and maybe you had something like this. And what you would have to do is go through and do all this distributive property. And get an answer like that. What we're going to do today is have, and oh, by the way, I forgot something. You can combine like terms right in the middle. So plus 10x. So we're going to have a problem like this, and we're going to have to come up with its factors. And remember what factors are. They're just things that multiply together to give you something else. So the factors of 8x squared plus 10x minus 3 are 2x plus 3 and 4x minus 1. Okay, so that's what we're going to have to do. So two very different things going in opposite directions. So this simplifying makes it a simpler problem, gets rid of the parentheses, and factoring takes an expression and turns it into two things that are being multiplied. Trinomials have three terms. That's what we're going to be working with today. Before we get there, let's review some things about factoring. What is the very first thing you are supposed to look for in any factoring problem? A greatest common factor in all of the terms. We're going to make a little flow chart here to help you remember when to do what. So very first thing, always, if you're asked to factor, look for a GCF. Does every term in the problem have a GCF? Okay. After you do that, the next thing you need to figure out is in your leftovers, how many terms are there? So this would not include your GCF, it would just be the leftovers. How many terms are there? Well, if there are 4 or more terms, we know what to do. That was the last lesson. If there's 4 or more terms, then we factor by grouping. And you're watching 9.3, so hopefully you have already passed your mastery check on 9.2, and you are good with factor by grouping. You passed your mastery check on 9.1, so you're good with pulling the GCF out. Well, what if there's not 4 or more? What if there's only 3 terms? Well, if there are 3 terms, we're going to do what we were learning today, and we call that AC method. Okay, there's going to be one more branch over here for 2. That'll be in the next lesson, 9.4. So for today, this is where we stop. And now we are going to learn how to do AC method. But before we do that, let's review what we already know. I'm going to add to this problem. So add in on this problem, add y squared, y to the third, and y to the fourth. So if I'm looking at this, I'm trying to find a GCF in all the problems because that's where I start every single problem. This problem has a GCF of 3 because 3, 12, and 15 are all divisible by 3. And if I look at my variables, they all have an x. How many x's would I be able to take out of each of them? Some students might have said 3, but can I take 3 x's here if I only have x squared? Here if I only have x to the first? No. I can't take x squared out. I could take it out of here and here, but I can't take x squared out of x to the first. So essentially what you're doing is you're picking whatever the common variable is, pick the one with the lowest exponent. So just to the first. Doing that same thing with the y's, they all have a y. The smallest exponent is 2. So that means I could take y squared out of each of these y's. And then you have to write what's left over after you take that out. That's what the factoring is. You're factoring it out. You're taking it out. So what you're really doing is division. So 3x to the third y squared divided by 3xy squared. Well, 3 divided by 3 is 1. It cancels. X to the third divided by x to the first, you really have to subtract the exponents. Y squared divided by y squared cancels. Negative 12 divided by 3 is negative 4. X squared divided by x, remember you're subtracting, so that would be to the first power. Y to the third divided by y squared, that's y to the first as well. Remember you're doing this with each one, so now do it with the 15. 15 divided by 3 is 5. Your x's would completely cancel, and you would have y to the second power left. Now, according to what I told you back here, your next question, after you take the GCF out, because that's what we did here, GCF, the next question is the number of terms. How many terms are there? In this case, there are 3, but I haven't taught you how to do this yet, so we're going to pretend we don't know that. Keep moving forward. After this lesson, though, at this point, you would have to look to factor even further. Okay, the next one, factor by grouping. Well, the first thing you got to do, still, always look for a GCF. Does every term have a GCF? No. So, the next question, how many terms are there? There are 4 terms. 4 terms is, of course, factor by grouping. So, we split it in half. The GCF in the first 2 is d squared. If you take that out, you are left with d from the d to the third minus, remember, there's nothing left here, but you can't not write anything. You must write a 1 because d squared divided by d squared technically is 1. Plus, oops, this is a typo. My goodness. Delete that 12. It's not supposed to be there. Fix that problem. Okay, then, if you look back here, there's no GCF in there. However, that d minus 1 is what we want here. So that means all we're going to write is a 1. Because if you factor out a 1, nothing's ever going to change. You're still left with d minus 1, but now you're in the correct format to finish factor by grouping. D minus 1 factors out, and d squared plus 1 is left. That is your answer. How do you check any factoring problem? You just multiply everything back out. All right, let's get to the new stuff. Factoring trinomials. Trinomials, again, have 3 terms. We are in the form ax squared plus bx plus c, right? So you always want your x squared term to come first. Here's the steps. Write them down on your paper where it says steps. First thing you want to find is AC. What operations between that? Well, if nothing's written, we know that's multiplication. So in this case, A is 2, right there, and C is 3. So AC is 6. Remember what I told you the name of this method is? AC method. That's the reason why. Because you start with finding AC. Okay, now here's the tricky part. Here's the hard step. You have to find 2 numbers that will multiply to whatever your AC is. So we're trying to multiply 2 numbers to get 6. And you might immediately think, well, duh, it's 2 and 3. But be careful. It's not always going to be what A and C are, because you also have to add to whatever your B is. Well, what's your B? Your B is 5. So you have to find 2 numbers that when you multiply them, you will get 6, and when you add them, you will get 5. Good morning.
What time do you want?
Okay, so things that multiply to 6. Well, 1 and 6 do. Is that going to add to 5? No. What if I made it 6 and negative 1? 6 minus 1 is 5. But then would that multiply to 6? No, it would multiply to negative 6. So that can't work. What else multiplies to 6? 2 and 3. Well, 2 and 3 multiply to 6 and they do add to 5. So yeah, in this case, it was your A and your C numbers, but it won't always be. So watch out. All right, once you figure out your 2 numbers, which we know now they are 2 and 3. Let me clean my slide up a little bit. I'm going to want to work underneath there. I don't need that anymore. So once you find your 2 numbers, which here they are, you are going to rewrite bx, which we know is this part, as the 2 numbers you just found. We're going to have to include the variable though. So 2x squared I'm leaving alone. But in place of the 5x, I am going to write plus 2x and plus 3x. And then I'm going to bring down my plus 3. Okay? So look at what we did here. I found those two numbers. After each of those, I included the variable that was there on the bx term. And then I put them right there. Why are we allowed to do that? Didn't I just change my problem? And I'm not allowed to change a problem. Well, take a look. What is 2x plus 3x? It's 5x, right? So I didn't change my problem. 2x plus 3x is still 5x. My problem is still equivalent. Well, then why the heck would you do that? Because it looks to me like you just took this 3-term problem and turned it into a 4-term problem. Doesn't more terms make it harder? Well, wait a minute. If you have 4 terms, you know what to do. How do you factor a problem with 4 terms? You factor by grouping. So we took a problem that we didn't know how to do and turned it into a problem that we did. Split it in half, take the GCF out. What's left then is x plus 1. In the back half, the GCF is 3. X plus 1 is left. If the things in parentheses match, you are on the right track. Factor out what's in those parentheses. So factor out x plus 1, and 2x plus 3 is what's left. And all that's left to do then is check your answer. How do you check your answer? You multiply it all out. 2x times x, 2x squared. X times 3, 3x. 1 times 2x, 2x. And 1 times 3 is 3. And if you combine those middle-like terms, you get a 5x, which sure enough, that is what we started with. Our answer checks. Pretty neat, right? Hopefully. You think it is. Okay, let's try another one. I left the steps up there to help you kind of go through them. But remember, this is once you've already decided it's AC method. So you still need to be going through these steps. Start with the GCF. Is there GCF in all 3 terms? No. How many terms are there? There are 3. That is AC method. So what is AC? Remember what you're doing there. You're just multiplying the coefficient with the x squared, which is 9, times the constant, which is 7. A x squared plus bx plus c. So A times C is 63. Find 2 numbers that multiply to whatever your AC number is and add to whatever your B number is. So we're trying to add to negative 64 and multiply to 63. Some of you are going to be very quick at finding these, and some of you are going to take a little bit longer. The easiest thing to do, though, don't start with this number, because you could have an infinite, number of, maybe not infinite, but a ton of combinations that will multiply, or I'm sorry, add to 64, but there's less numbers that multiply. So always start with your multiplication. Well, 9 and 7 is the first thing I think of, right? But that's definitely not going to add to negative 64. I need the biggest number, it's actually bigger than 63. I always look at it without the sign first. If you don't immediately see it, the best thing to do is write out all of your factors. Start with 1 and that number. So how about 1 and 63? Bingo! What do your signs need to be? So once you figure out the numbers, figure out how to get the sign to work out. Well, I think I would need them both negative. Negative times a negative multiplies to a positive. But negative 1 minus 63 is negative 64. So once you find your 2 numbers, rewrite bx as the 2 numbers you just found. So 9x squared minus 1x minus 63x plus 7. And again, the reason you're allowed to do this is because this is equivalent. Minus 1x minus 63x is negative 64x. So why do we choose to do that? Because now you have 4 terms and you know how to factor when there are 4 terms. You factor by grouping. The GCF in the first half is x. What is left is 9x minus 1. The GCF in the back half is a 9, but look at your signs. You have a negative and then a positive. That's what would be left in your parentheses, but we need a positive and then a negative. So I'm going to think ahead and I'm going to recognize I need to factor out that negative. because I don't want this first term to be a negative in my parentheses. I want it to be a positive. So a negative 9 comes out. I'm sorry, not a negative 9, a negative what? 7. Obviously, I can't take a 9 out of 7. But when I take the negative 7 out, then I'm left with 9x minus 1. My parentheses match, 9x minus 1 and x minus 7. That's my answer. Okay? Next one. Go through your flowchart. Is there GCF in all three terms? No. How many terms are there? 3. So that's AC. AC method says, what is AC? It is negative 24. Make sure you include signs. 3 times negative 8. That's your AC. Your B is negative 2. Okay, so you need to figure out what two things multiply to negative 24 and add to negative 2. If you don't see it right away, here's what you should do. Write out all the terms in order, checking them as you go so you're not doing more work than you need. So would 1 and 24, and again, ignore the signs at first, just 1 and 24, could you add or subtract them in any way to get 2? No. 2 and 12, add or subtract to get negative 2? No. 3 and 8, no. 4 and 6, yes. What would your signs need to be to multiply to negative 24, which means one has to be positive, one has to be negative, and add to negative 2? So which one's positive, which one's negative? Hopefully you said positive 4, negative 6. Once you find those two numbers, you replace your middle term with them. So positive 4x, negative 6x, minus 8. This problem is still equivalent. It's still equal to itself. But now there's 4 terms, so you can split it in half and factor. GCF in the first half is 3x plus 4. In the back half, these are both negatives. I'm going to want my parentheses inside to be positive, so I need to factor out the negative. Factor out a negative 2 because that's the GCF. That leaves you with 3x plus 4. If you've done it correctly, your parentheses will be the exact same. That's now your common factor, so that factors out, and what is left is x minus 2. Again, you can always check these by multiplying them out, and you should be doing it every time. I'm kind of skipping that because I've done these problems, I know they work out, but when you're working on your own, definitely check them. Something else that usually students will ask is, does this order matter? So real quick, let me show you. Let me put them in the opposite order, because maybe somebody else would have thought negative 6 and 4 instead of 4 and negative 6. So if I put negative 6x and then 4x, so you can see that they're the opposite order. I'm still going to split it in half. Now my GCF is 3x. I'm left with x minus 2. And back here it's a 4. I'm left with x minus 2. I factor out my x minus 2. I'm left with 3x plus 4. Compare my answers. Are they the same? Well, they're in a different order, but this is multiplication, right? Does order matter in multiplication? No. So I could take either one of these answers and it would be perfectly fine. Okay, it doesn't matter which group of parentheses is first. So that means it does not matter which order you plug the numbers in for BX. Okay. All right, what do you start every factoring problem with? A GCF. Is there a GCF in all three terms? Hopefully you didn't just quickly say no. Hopefully you're actually looking, because yes, there is on this one. What can you divide each of these by? 2. So I'm going to factor out a 2. 12x squared minus 19x plus 5 is what is left. Now, same way we did it, whoops, that one shouldn't be there. Same way we did it before, you want to take this 2 and bring it all the way down into your answer. You don't want to forget them. Okay, then you're looking at your leftovers in the parentheses. 3 terms in the parentheses, so we are going to do AC method. AC is 12 times 5, which is 60. We need to find two numbers that multiply to 60, but that will add to negative 19. Well, I don't immediately see it, so let's write out all the factors. Are 1 and 60 in any way going to give me negative 19? No. 2 and 30. Notice I'm going in order. 1 times what? 2 times what? 3 times what? And I'll keep going. 3 and 20. I don't think so. 4 and 15. That's an and sign. I think 4 and 15 could work. What signs do they need to be? Well, if I'm multiplying to get a positive, they have to be the same sign. So maybe both positive, but then I would never get a negative here. So maybe both negative, and sure enough, that works. I've already taken care of my 2, so I'm ignoring that now, and I'm just looking in here. So 12x squared minus 4x minus 15x, and remember, those can go in either order. It doesn't matter, the middle two numbers. But now, factor by grouping. There's 4 terms, so we split it in half. 4x comes out. 3x minus 1 is left. Don't forget your 1. GCF in the back is 5. Oops, I forgot the negative, or I forgot the, okay, hold on. I corrected my writing and I did it wrong. It's minus 15, not plus 5. I couldn't read what I wrote. So 5 is still the GCF, but now negative 3x plus 1 is left. Now, I made a mistake here, right? My parentheses don't match exactly. So I need to fix that. The way I would do that is instead of factoring out a positive 5, I could factor out a negative 5. So if I'm factoring out a negative 5, this would become positive, and this one would become negative. Okay, so make sure you've got your signs matching. Then 3x minus 1 is left in each parenthesis, so that factors out. And what is left is 4x minus 5. Make sure you include that 2 GCF as part of your answer. Okay, taking a look at this problem, this is not in the right order, right? So you always want to make sure you are starting with your squared term, then your term to the first power, and then your constant. Okay? Take out the GCF if there is one. Sure enough, there is. It's a 2 t squared plus 7t minus 18. Okay, I'm going to bring my 2 all the way down. So now I'm just looking at this stuff. AC is 1 times negative 18. That's negative 18. So I need 2 things that multiply to negative 18 and add to 7. Hopefully you're thinking 9 and 2, and the 2 has to be a negative. 9 times negative 2 is negative 18, and 9 plus negative 2 is positive 7. So I'm going to replace my middle term 7t with those 2. I get t squared plus 9t minus 2t minus 18. 4 terms means I can factor by grouping, split it in half. T comes out, t plus 9 is left. In the back, what's the GCF? A negative 2 to make my signs match. T plus 9 is left. So I have this part now becoming t plus 9 and t minus 2. Let me pause right there before I put my whole answer together. What were my numbers? 9 and negative 2 over here. Look at my answer. 9 and negative 2. Did that happen every time? Well, back here my numbers were negative 4 and negative 15. That's not what's in here. Here I had 4 and negative 6. That's not what's in there. Here I had negative 1 and negative 63. That's not what's in there. One of them is, but not the other. Back here, 2 and 3. Well, no, I had a 1 and a 3. So what's different about this problem that worked out that way? Well, when you did your AC method, what was your A? It was 1. Here's a shortcut. if a is 1, your two numbers, and by that I mean the two numbers that multiply to AC and add to B, can go straight into your parentheses, straight into your answer. I will show you this again, how to take that shortcut. But write that down so you've got it. Do you have to take this shortcut? No, it's a shortcut. You are welcome to continue doing it the long way, the full out way. But if you see the shortcut, sure, why wouldn't you take it? So to finish your answer, you already have your GCF of 2. Now include your t plus 9 and your t minus 2. All right, let me get you another one that has the shortcut. Okay, so first thing, GCF in all the terms? There is not one. How many terms are there? There are 3. So AC is 1 times 12. So is this one you could take the shortcut on? Yes. The shortcut is able to be taken if A equals 1, which it does here. So what are the two numbers? Two numbers that multiply to 12 and add to negative 7. 4 and 3. What do the signs need to be? Negative 4 and negative 3. If A equals 1, you are able to take your shortcut. And what that means is you can go straight into your parentheses. You don't have to do any of that work in the middle. Negative 4 and negative 3 are going to go in your parentheses. Well, what's going to go in the front of the parentheses? What goes in the front of the parentheses is whatever you're going to multiply to get that. What do you multiply to get x squared? X times x. That's your answer. Check it out. X times x is x squared. Then you'd get a negative 3x, a negative 4x, which sure enough is negative 7x, and negative 4 and negative 3 is positive 12. Very quickly, if I did it the long way, if I did it all out without no shortcut, I would have had this. Factor by grouping. I would have had that. Factor out that, and this is what's left over. The exact same answer. Okay, when can you use the shortcut? Only when A is 1. All right, I'm going to have you guys do the next two here. Pause the video, try the next two. Two tricky ones. First one's prime. How did I know that? Well, AC is 14. I went through all of my factors. 1 and 14 won't add to negative 11. 2 and 7 won't. 14 doesn't have a factor of 3 or 4 or 5 or 6. And 7 and 2 is just repeating what I already had done. So I'm done checking. There's nothing to be doing here. It is prime. The second one, I did the shortcut on. Because A was 1, I found two numbers that multiplied to 24 and added to 11. I put them in here. And what times what gives me x squared? X times x. You can always check these by multiplying them back out. Okay, you guys try these two. Okay, check your answers. Number 11, you could have taken the shortcut, but it would work out if you didn't. And number 12, I put these in potentially the opposite order that you would have, just to show you that it'll work. Maybe that is the same order you have. Don't forget that GCF, pull it out. Had you forgotten that GCF, you might have ended up with an answer of 6x plus 4 times x plus 1, and you can't have that because these have a GCF of 2. So even if you didn't do it at the beginning, you need to then do it. Take the 2 out, you'd be left with 3x plus 2 and x plus 1. Or maybe you had 3x plus 2, but you had 2x plus 2. These have a GCF, so you have to take that out. So I'm pulling it all the way out to the front, and then I'd be left with x plus 1. So you always need to make sure your answer has no GCFs left in any of the factors. Okay, last one. I know this is a long video, but this is a very important section that you will continue using all the way through your senior year of math. So super important that you get it. Single page. Nope, that's not what I wanted. Okay, the area of a rectangle is 2x squared minus 13x minus 7 were the possible dimensions of the rectangle. We did the same thing with volume already. Now we're just doing it with area because area is length times width. So we're trying to find two factors of this. Well, if you're trying to find two factors of this, that means you need to factor the problem. Pause the video, you guys factor this out. Okay, factoring gives me this, so these are my two possible dimensions for that rectangle. All right, again, I know it's a long video, but it's super important, so go ahead and get started on your packet now.